Hi, good morning, everyone. Yeah, thanks for coming. So today I'm going to talk about how NDIS leverage RISC-V for computing devices. So always slash, so we're almost there. So this market research done by STHD Group, probably everyone's seen it, but I just kind of repeat it again. So this one is for 2024 version. So for RISC-V SoC revenue in 2023, is about 2.8x over the previous year. And from that point to 2030 is another 15x growth. So even though it divided this number by 2, it's still quite amazing, quite encouraging growth for everyone. So in this report, also mentioned that NDIS has over 30% of RISC-V IP shipment market. So where we cover all different applications like mobile, peripheral, all kinds of storage, MCU, MPU, 5G networking, and also certified automotive market. And last but the most, large-scale AI and machine learning. So most of the applications are in the edge, but in last category, we have several customers in the cloud, like Meta, Reverse, Sapient, Fractile, Rain AI, and so on. So today's focus will be in key technology enabled by RISC-V, standard extension, as well as custom extension. So 4 of them are large-scale AI machine learning, acceleration, general-purpose application processing, embedded real-time, functional safety, and security. So together, they are the core of what NDIS use to enable our customers. So first, large-scale AI machine learning from edge to cloud. So the popular SoC architecture is what I call COP, either mesh-connected, like Meta's MTIA, or multi-cluster, and where the main computation happens inside the processing elements, or PEs. So there are 3 tiers of acceleration in PE. First one is matrix multiplication. And often there are hardware solution, but RISC-V also working on integrated matrix extension, IME, and also AME attached matrix extension. So NDIS is quite active involving the IME. We do a lot of presentation there because I think the instruction for matrix multiplication is quite important to make software easier to use and also compiler. And the next one is a nonlinear activation function, which continue to evolve, like softmax, sigmoid, and so on. So the best way to handle it is to using custom extension, like in this automated custom extension ACE, to connect to customers' existing hardware accelerator, like the one you see on the bottom, which Meta use. Or you can design the like softmax function directly using ACE to implement the vector instruction. And last will be RISC-V vector extension, which can catch all and future-proof for the remaining smaller parallelism. So we just announced this new vector processor, X46 MPV, which is built on, so NDIS has a series of vector processor, and 46 is built on the success of 45 MPV, which has an 8-core cluster with up to 10 bits VLAN and DLAN, and dual issue for vector and scalar. So 46 MPV double the core count and also VLAN to 2K bits, and enhance custom extension capability for custom to add scalar and vector instruction, and also matrix extension there. But also very important is boosted memory performance. So we enhance it to allow it to execute 2 low or 1 low, 1 store, either vector or scalar instruction. And we provide private L2 cache for those who prefer flat memory programming. And also HVM is a high-speed vector memory interface. We make it even better. So it can issue multiple outstanding requests and with auto-order data return. And we also implement HVM controller, which can support up to 16 cores with DMA port coming in. On the other side, it's up to 64 banks of SRAM. So x64 MPV has a non-vector inclination and also 32-bit inclination. So we have 4 of them in 46 series. So software is as important as hardware, if not more important. So for AI machine learning, we have NDIS-L. NDIS-AI runs everywhere. And software stack from the end-to-end tool. So from the top, take AI model and convert it down to the immediate bottom to execute on the hardware. So on the top is NDIS-L and NMPiler, which is our proprietary tool, which take graph level, do optimization, as well as doing the machine level, the process level optimization, generating the right optimized process instruction. We also leverage quite a few open source tools and also can contribute back our enhancement. So first is LVM auto vectorization. And we also use ERI, which can invoke microkernel, which can be optimized with the standard RISC-V instruction or our custom generated custom instruction using ACE. And NDIS invented Auto ERI, which is an automatic tool to find a better tiling strategy. And using mobile NetV1 as well as mobile BERT, you can prove that it can produce over 2x speed up over just using ERI alone. So NN library, which is, has over 200 optimized library to support the NMPiler generated bare metal runtime. And we also have XNMPeg optimized high-level function to support PyTorch and TensorFlow Lite. And there's still a lot of RISC-V function there which can be used to continue to optimize. So we contribute what we ported, and we also welcome more community to come to join us to do the optimization. So the next is general purpose application processing. So this is for either you serve as control or main processor for personal computing, like a smartphone, tablet, PC, all the way to data center server, as well as AI machine learning, multimedia, networking. So the requirement for this kind of support is, first, you certainly need high-performance processor capable of running Linux and Android. And the community from the RISC-V RVI, we set up the standard for RVA 22 and also now 23 profile. So this is very good standard for everyone to follow to the hardware. And also we have all the major Linux distro and also Linux build system already support RISC-V. And there's also Android AOSP. And also, and this is also part of the RISE, kind of pushing for more and more important piece of software to optimize and porting and optimize it to RISC-V. So in this application processor, and it already has this AX60 series, which is 13-stage, 4-way out-of-order, Linux-capable, multi-core coherency, and up to 8 core. The first member is X65, which we announced years ago. It supports RVA 22 plus. Its spec 2006 per gigahertz is 8.78, which is pretty good for the two-level memory hierarchy processor. And we just announced X66, which is 15% more performance over 65. And it supports RVA 23. So that can naturally support the Android base, which covering vector crypto, hypervisor, and AIA, and so on. It also has it added a private L2 cache, which is optional, and also CHI for multi-cluster cache coherency. So for X66, we're adding the vector support, which can be configured as 1 pipe or 2 pipe, and it will share with a 14-point unit. And you can execute any combination of ALU and low store instruction in that FPU pipeline, if you have 2 pipes, of course. And the one beyond that is 67, which we expect to have another 10% performance boost and also catch up the new feature after RVA 23. And X63 is power optimized and custom driven. So we turn down the performance, but kind of optimize it for the power consumption. And also we work on a project in parallel called Cusco, which we had from high level, it has similar feature as 66 or 67, but this has a unique 16-stage, 8-way, 6-way configurable auto processor with our patented time-based scheduling. So its performance will be 50% to 2x over 66. Right, embedded in real-time system. In some application, in this domain, code size is very important. So the recently ratified ZCE bring about 4% reduction, and scalar efficiency task group continue to work toward that direction. But meanwhile, NDIS V5 custom extension, including code dense, can bring another 11 to 15% code size reduction for those who need it. And some of the applications inside those embedded real-time systems, they need to have efficient control and access of their hardware engine. So all NDIS core support multiple outstanding and access to on-cache and device space. And for those who need to take it one step further, like our customer Phison, they use async instruction with custom port and a very wide bus directly connect to the hardware engine they want to control. And interrupt handling is also very important. So single issue, single core, there's a click there, hopefully can be rectified soon. And for multi-core, NDIS extend the prick with vector dispatch and priority preemption. And for some applications really require very short interrupt latency. For that, we support shadow register so that interrupt service routine doesn't need to save any register before they start processing. And there's also quality of service, which is quite important. So RISC-V has this capacity and bandwidth QoS register interface. And this already implement the capacity management hardware there. So this is the initial evaluation result. So 4-core with a 16-way share cache. So I get 30% boost in memory copy if you allocate a 4-way to each core instead of letting 4 cores sharing the 16-way. Right, so functional safety and security, I think ISO 262, you need to start from a development process certification. And based on that, you design your product, a certified product. So NDIS already had 2 CLB product, and now we are working on a CLD level. So we just announced D45 SE, which be the dual core last step and with all the features to get certified at a CLD. And we are working on D23 SE, and also more will come in. And we're also working on hardware secure module, which is very important to protect key and crypto function for cybersecurity, and is controlled by our security core N225. And RISC-V here bring a couple features there very helpful for the application, including IERI, NMI, EPMP, and also like ongoing security standard like IOPMP. And ecosystem is actually very important here. So NDIS is quite active to bringing new partner to the RISC-V to share with everyone. So in the different domain here, for in particular for automotive. Okay, so in summary, NDIS has over 30 NDIS core, from tiny small one to the large RVA 23 capable. So they all support RISC-V standard extension, and we provide ACE tool to help customers to automate the extension that they like to add in. So we talk about upcoming core, vector processor, X46 MPV, and the application processor. x66 and Cusco, they will be RVA23 and plus. And a CLD level core, D45SE and D23SE. And they enabled the key computing technology we talked about earlier. So with 20 years in pure IP business player, and 30 plus RISC-V core, and 15 billion SoC based on Andes core. So I think Andes is in a position to help bring RISC-V vision to reality, 1 billion SoC at a time. All right, thank you.